In this chapter, we're going to be going over odds. So odds are going to be used in many real-life applications, including sporting events and games of chance, as I'm sure that we know. So starting with the first one is odds against an event. So this is going to be the one that we are probably used to. These are going to be the odds that they use at gambling venues or for sports. And what this is it's going to be a ratio of the probability that the event will fail to occur to the probability that the event will occur. So written as a ratio or a fraction, the odds against an event is going to be the probability the event fails to occur divided by the probability that the event occurs, which we can just remember it as the probability of failure divided by the probability of success. So let's go ahead and look at this example. Let's determine the odds against rolling a 4 on one roll of a fair die. So we need the probability of success, which is going to be the probability of rolling a 4, and the probability of not rolling a 4. So first, the probability of rolling a 4 is just going to be 1 out of 6 because we have one possible outcome that results in a 4. And then we want the probability of not rolling a 4, and that's going to be 5 over 6. There's 5 numbers that are not 4s, so it's going to be 5 over 6. So this is going to be the probability of failure over the probability of success. So we are going to divide these. We're going to do failure 5/6 divided by 1/6. And when we are dividing fractions, we have to remember that we can use the phrase keep, change, flip. We're going to keep the first one the same, change it to multiplication, and we're going to reciprocate or flip the second one. The 6's will cancel. 6 divided by 6 equals 1. So we're left with 5 times 1 over 1 times 1, which gives us 5 over 1. So that means these odds, the odds against rolling a 4 are 5 to 1. Okay, so there's actually a shortcut that we could have done for this. In an experiment with equally likely outcomes, the odds against an event can also be found using this formula. So the odds against event E with equally likely outcomes, it's going to be the number of outcomes unfavorable to E divided by the number of outcomes favorable to E. So if we were doing the same exact problem, it's going to be the odds against rolling a 4. It's going to equal the number of outcomes favorable to E, or unfavorable to E, so that's going to be 5 outcomes unfavorable to rolling a 4. It's every other number except for a 4, divided by 1 outcome favorable to rolling a 4, which is just rolling a 4. So that's going to be 5 to 1 once again. So or 5 to 1. Okay, so that's because if it's equally likely, then as we saw up here, those denominators are just going to cancel and we're going to be left with the numerators. So for the next example, we have a pie chart shown which shows the US smartphone ownership in 2014. And if a smartphone owner is randomly selected, we want to determine the odds against the individual owning a Samsung phone. Okay, so for the odds against them owning a Samsung phone, it's going to be the probability of failure. So in this case, the failure is going to represent them not owning a Samsung phone divided by the probability of success, which is the probability of them owning the Samsung phone. So let's find the probability of owning. Let's do the denominator first here. So the probability of owning a Samsung phone is going to be 27%. So we have to know that 27% represents 27 over 100. Definition of percent for every 100. So that's going to be the denominator. So it's going to be divided by 27 over 100. So now we need the percent not owning a Samsung phone. So for the percent not owning a Samsung phone, you can add up all of the other ones and then put it over 100, or you can do 1 minus 27 over 100, and that's going to give us 73 over 100. Okay, so on this one was considered success, this one's considered failure. Okay, so let's go ahead and plop that in this equation. So it's 73 over 100 divided by 27 over 100. So when we are solving this, it's going to be keep, change, flip, keep the first one the same, change to multiplication, and we recognize that the 100s will cancel because these were equally likely outcomes, and we're going to be left with 73 times 1 divided by 1 times 27. So we get 27 or 73 over 27, or we can write it as 73 to 27. Okay, so the odds against one of these randomly selected users owning a Samsung would be 73 to 27. So we could have recognized that these were going to be equally likely outcomes because they both had a denominator of 100 because they were both percents. So we could have just done 73 divided by 27, and that would have been our answer right away. So for the next one, we have odds in favor of an event. So the previous one was odds against an event, which is the more commonly used one. This one is odds in favor of an event. So the odds in favor of an event are going to be a ratio, the probability that the event will occur, divided by the probability that the event will fail to occur. So it's going to be the reciprocal numerator and denominator are just flipped compared to the one that we just did. So it's going to be probability of success divided by probability of failure. So we can use that shortcut. If we have the odds against and we know it's A to B, the odds in favor are going to be B to A. So we just have to reverse the order. So it's pretty simple if we have one of them. So let's go ahead and do this example. One card is selected from a standard deck of cards. We want to determine the odds in favor of selecting a queen. So this is going to be the probability of success divided by the probability of failure. And in this case, it's going to mean the probability of selecting a queen divided by the probability of not selecting a queen. So the probability of selecting a queen is going to be 1 out of 13. And that's because that comes from the fact that there are 4 queens out of 52 cards, simplifies to 1 over 13. So the probability of not selecting a queen is going to be 12 over 13, and that is going to come from the fact that we can just simply do 1 minus the probability of selecting the queen. Okay, so, or you can think of it as there's 48 other cards, 48 over 52 simplifies to 12 over 13. So we went through and we did keep, change, flip here. We kept the first one the same, changed to multiplication, we reciprocated the second one, cancel those common factors of 13. We get 1 times 1 is 1, and 1 times 12 is 12. So this is going to be 1 over 12, or 1 to 12. So these are the odds in favor of. Okay, so typically we don't see it like that. We see it as the odds against, which is part B. So the odds against, since we know the odds in favor, it's just going to essentially be the opposite. So the odds against selecting a queen are going to be 12 to 1. Okay, and just like before, when we have an experiment with equally likely outcomes, we can simplify that formula down a little bit, and the odds in favor of event E, so I just have to change this. This should say in favor. The odds in favor of event E are going to be the number of outcomes favorable to E divided by the number of outcomes unfavorable to E, which in this case we could have just recognized this with the queens, and we could have done, instead of 1 over 13 divided by 12 over 13, as we did up here, we could have just done 1 over 12. Okay, so for the last thing here, we can find probabilities when we're given the odds. So when odds are given, either in favor of or against an event, it's possible to determine the probability that the event occurs and that the probability does not occur. So the denominators of the probabilities are going to be found by adding the numerators in the odds statement from the question. So let's see what that means in an example. So for example, the odds against Robin being admitted to the college are 9 to 2. We want to determine the probability that Robin is admitted. So we know that we're given the odds against, and we know that odds against is going to equal the probability of failure divided by the probability of success. In this case, probability of fails to be admitted divided by the probability that she is admitted. So based on what we're given here, it's 9 to 2, which you write as a fraction as 9 over 2. Okay, so all we have to do is go ahead and take a look at the numerator for fails to be admitted, denominator for is admitted. So the first question is that she is admitted, so that's going to be the denominator. So the probability that she is admitted is going to be 2 divided by something, so that denominator, because that's the admitted one, the denominator, so it's going to be 2 divided by something. That something is what was mentioned up here in the instructions. You have to add these numbers together to get the denominator for both of these probabilities, and we get 11. So this is going to be 2 over 11. Okay, and then for this last one down here, the probability that she is not admitted, it's going to be the same exact concept. It's going to be 9 in this case because that's the numerator, fails to be admitted, divided by the total value of 11 that we got when we added them together. So we get 9 over 11. So we could have also gotten this by doing, I'll put or, you could get it from doing 1 minus 2 over 11, and you would have gotten the same exact thing. Okay, so that is it for this section with odds.